first of all, happy Diwali to all of you. Stay happy and healthy. So today our topic is how to notate the P wave and S wave that travel through the Earth's surface or Earth interior. Okay. So note down the first point. P wave or S wave that travel directly from an earthquake is notated as P wave and S wave. Okay. So the wave that travel directly from an earthquake in the Earth's surface is that we call P wave and S wave. Now, second point is that the wave that reaches the seismometer after being reflected once from the crust is labeled as PP or SS. So, the wave that reaches the seismometer, we know the earthquake wave will reach the seismometer after some time and travel some distance. After being reflected once it is reflected from the crust, when it reaches to the crust, it gets reflected, and that P wave and S wave will labeled as PP and or SS. If we are considering P wave, then we call this PP. If we are considering S wave, then it is called SS. Okay. Now, the energy of incident P wave or S wave is personated at interface into the reflected and refracted P wave and S wave. So when it strikes the interface, suppose this is the interface, the P wave is coming from this side. Some part of this reflect, and some part of this this is refracted, and this will be some part of this will reflected. Okay. So we notate we give notation accordingly. So now note down the other important points. So now, for P wave incident on the mantle, on the boundary between mantle and fluid outer core. Remember, outer core is in fluid state and inner core is in solid state. So, P wave incident on the boundary between mantle and fluid outer core is refracted towards the normal. So, the P wave will refract towards the normal when it passes through the outer core. Okay. The boundary between mantle and outer core is reflected towards the normal to the interface, because the P wave velocity drops from 13 km per second to 8 km per second at the boundary. So when it passes through the boundary between outer core, fluid outer core and mantle, the velocity drop is from 13 km per second to 8 km per second, and the wave, the incident P wave will bend towards the normal, because outer core is in a denser state, and the mantle is in dense, and this is rare medium and this is denser medium. So when a wave travels from a denser rare medium to denser medium, in the denser medium the wave will bend towards the normal. Now, second point is that after a second refraction, it emerges beyond the shadow zone. Now, when it will when there is a second refraction, the wave will emerges beyond the shadow zone. So, we will talk about the shadow zone. We will discuss it later in this lecture. So, this is called PKP. So, remember the P for P wave and K for kern, because the kern is called, this is core. In German word, kern is called core. So I have written here also K for kern, German word for core. So K for core, and this is the German word, and it means core. Is S wave incident on the same point has a lower mantle velocity of 8 km per second. The refraction is away from the normal to the interface. So when S wave will suffer incident on the same point, has a lower mantle velocity of 8 km per second. The refraction will take place away from the normal to the interface. Now I will discuss it in the next point. This wave is what we call SKP. Okay, so I will deal this in the next point. So I am talking about S wave. So after further refraction of S wave, the incident S wave reaches the surface as SKS phase. So this is the notation SKS when it is refracted from the core curve and reaches to the surface, then it is called SKS wave. Okay. Now a P wave that travels through the mantle, fluid outer core and inner core is labeled as PKIKP. So it travels through mantle, it travels through fluid outer core, it travels through inner core, then further it travels through inner core, then it reaches to the surface. Okay. Each of these rays refracted at an interface, at an internal interface. So each of these rays will refracted at an internal interface. Now, to indicate the seismic wave phase that are reflected at outer core boundary, the letter C is used. So for letter C, this is the reflection C. The letter C is used for reflection from the outer core boundary. Okay. Example PCP SCS phases. Now I will show this in the entire things in the diagram, so that your concept will be very clear. Now reflection from inner core designated with letter I, and the notation is PKIKP. So I will show this in the diagram so that your concept will be very clear. So now in this diagram I have shown the notation PCP, the notation PKP and the notation PP. So what are these? So suppose this is focused, earthquake is occurring here and the wave is traveling in all the direction. So suppose this is my first wave. So it started from here and it strike here at the interface between the fluid outer core and the mantle boundary, and some part of this is reflected back towards the crust. This is the crust, and the back, the wave that is reflected back towards the crust is called, we call this PCP because this is P, and since here the reflection takes place, the notation C is used, and since it is going back to the mantle, the notation P is used. So the entire notation is PCP. Now some part of this will refracted towards the outer core. So the notation this is P, and now the notation K will come because they have refraction taking place. So this is K for the outer core. Now after refraction, the second refraction will take place somewhere here at this point, and after this refraction it will back to the mantle, and the notation P is again used. So here PKP, this is PKP. Now another wave is, it started from here and it reaches to the point P, this is P, and after reflection from the crust, this is again P for the mantle. So now this is P and P, this is P and this is P. Okay. So now in this illustration, suppose this is the entire earth and earthquake is occurring somewhere here. This is the focus of the earthquake. Now all the waves will be generated here, P wave and S wave, like that. Now suppose I am considering P wave, it started from here, it originated from here, and it traveled through the mantle and strike the interface at the crust, and it reaches to the again crust. So when it traveled through the mantle, this is P, and it strike here and reflected back to the mantle, and here P. So the notation will be PP. Okay. Now this is the second refraction taking place. Suppose this is the P wave starting from here, and here the reflection and refraction both took place. So this point will be noted as C, and when it is reflected back to the mantle, this is called P, and this is the P. So here this is the PC because it is reflected from the interface between the mantle and outer core, fluid outer core. So the notation will be PCP. Now it is some portion will be reflected and some portion will be refracted. Now it is refracted toward the mantle, like fluid outer core. So the notation K for current, that is outer core. Now this is PK, and again it reaches to the mantle, so the notation will be PKP. Now another thing, the P wave started from here and it traveled through here. The reflection takes place at S. The refraction takes place at S. So this is I am talking about S wave. So the notation S is used here. So it is traveling through mantle. So notation S is used. Now the notation K is used for the outer core. Now the notation I is used for the inner core. Now the notation K is used for the again outer core. Now the notation S is used for again mantle. So the entire notation is SK IKS. Now the P wave, for P wave it will travel like this, and it reaches to outer core. This is P, and it reaches to outer core. We call this K, and it again enter the inner core. So notation I is used. Again it reaches to the outer core. So the notation K is used. Now again it is back to the mantle. So again I is used, P is used. So the entire notation is PK IKP. Now we have covered all those things. Now for S wave, it is traveled from, it started from here, it strike here, and again it enter the outer core, and again it back to the mantle. So the notation SKS is used. So this is S, K and S. Now this is the S wave, and from at this point, this is the point C, because the reflection is taking place here. It is reflected back to the mantle. So this is S, C, S. See the S, C, S. Now some part of the S wave will be reflected from the crust also. So this is S, and when this is S for mantle. Now S for the mantle also, because it is reflected from the mantle here. So the notation SS is used. So all the notation is covered here. So now here the shadow zone, I am talking about the shadow zone. So the shadow zone of P wave and S wave due to refraction of seismic wave because of presence of outer core. So you know the presence, so due to the presence of outer core, the shadow zone is created, because S wave cannot travel in the outer core because of the fluid state. Now at from 103 degree to 143 degree, shadow zone of both P wave and S wave exist. From 103 to 180 degree, shadow zone of S wave only exist, and from 143 to 143 degree, shadow zone of S wave only exist. Okay, so I will illustrate this in the diagram so that you will be clear in this topic. So now here I have mentioned what is the shadow zone. So suppose this is focus. Here the earthquake is occurring. So here P wave is generated. So it travel along this direction, and here it is reflected. So here the notation C is used from the outer core and mantle boundary. So here now it reaches to the somewhere here P. So the notation P is again used. So this is 103 degree. The entire is 360 degree. Now another wave is generated here, and it travels through this point and reflected this point, and here again the refraction here the refraction taking place, here the reflection taking place, again the refraction taking place. So it reaches to here. So this point is called PKIKP. And now again this is 143 degree. So in this zone no P wave is formed. So this is called P wave shadow zone. From here to here, this is the P wave shadow zone, from 103 to 143 degree. Now again here this is again 103 degree, again this is 143 degree, again this is a P wave shadow zone. Now this entire part, this is the 180 degree, this is 180, and again this is 180, total is 360 degree. 180 plus 180, 360 degree. The entire is 360 degree. So the half part is 180 degree. So this half part we call the S wave shadow zone, because no S wave reaches at this entire zone. Okay. So now here I am illustrating the S wave. For S wave, how will the shadow zone will create. So this is the S wave, the point wave is generating here. So it traveled through this point, and it reflected from this point, and it reaches here. This is 103 degree. and again this is starting from here. This is the outer core. This is the outer core and mantle boundary, and it refracted from the outer core boundary and reaches the inner core boundary. It refracted from the inner core boundary, outer core inner core boundary, and it again reaches to the outer core boundary and outer core and mantle boundary, and again it is refracted at this point 143 degree. So this is also same. So in this part, in this entire part, no S wave will be seen. No S wave will be recorded in the seismograph. So this is called S wave shadow zone. Okay. Now this is the end of the lecture. In the next lecture, I will talk more about this. And thank you for your patience. And if you have not subscribed our channel, subscribe our channel. And now thank you for your patience.